It's not important. This is not important. Please hopefully kill himself. Evaporate. Ah. Okay, what I'm planning for today, we can start, I hope. For today I'm planning one, how to say, supplement or addendum. It's a solution of linear systems. What's going on? Where is my... No, it's not all. Something wrong. something wrong. Oh, this way better. Yeah. I have one supplementary thing, actually two supplementary things. First is systems of linear equation. It's one thing. And another is how to solve them numerically. First, I will use my blackboard, then I will be able to switch to computer. It's a computer application, time to do something numerically. Machine works, human relax. Okay, where to start from? As you saw previously, I have conducted Ohm equation. Yeah, I can also conduct what kind of equation? Node voltage and contour currents. They all fell in same class of equation. It's a class of linear equation systems. Systems like AX equals to B, where A is a square matrix A11, A12, A1n, A21, AN1, and the last one will be AN. Something familiar? A to N and so on. X unknown will be X1, X2. In our case, voltages on currents, and B, free elements starting from B1 to Bn. You wait. Yeah. So, we have a system with a square matrix n by m and two vectors of n elements. N will be number of nodes or number of contours. Nice, nice, nice. How can I solve it? System of linear equation. How should I solve it?
B is that one? B1.
B1, B,
B.
and then
Okay.
it will be something electrical, I hope.
B is just a raw matrix.
In our case, B will be all so-called definitive current or definitive currents, currents in flow in nodes, or contour EMF. You'll see, don't worry. At this point, there are some abstract numbers. How can I solve such system? How? Simplest case, A11x1 plus A12x2 equals B1, A21x1 plus AX2 equals to B second. And like this. How will I solve it? What's your school experience?
equation, sir? Like you multiply it, a into x equal to b.
Very. Huh? I can draw it geometrically. x1, x2. First equation, maybe this line. Second equation, straight line, and your task is to find this cross point.
Ah.
It's what is in geometry. So, what's the idea of your school? How to solve it? It should be in your program. What is silence? At the first step, you need, for example, take second equation, so, and obtain a clear second x from it. So it will be v2 minus a to 1 x1 and divided by a to 2. Yeah? And then substitute it in the first equation. What's the name of this technique? And then the 6 goes here. And you get solvable equation for x1. You get x1, and then using this, you get x2. What's the name of this technique? Gauss technique. Actually, it's a standard or reference point for linear system solution. It works, really works, but there are small problems. Problem number one, see, there always is division by main diagonal element. It should not be 0. If you try to solve Kirchhoff's equation, oops, there are a lot of zeros. So you will need to reorder your system, reshuffle rows and columns to get the A matrix in form that there will be no 0 on the main diagonal. But that's not all. Actually, the problem is deeper. When you look at the process of Gauss solution, you'll see, one moment, each next, actually Gauss solution has two main steps. At the first, how to say, stage, from the system, this square matrix, you go to the system with triangular equals to some, here will be x, here will be some kind of figure. You will go to system with triangular matrix. It's so-called forward stage. And then you will perform a backward stage, return stage, to obtain this last row will give you last unknown, and you going up will get them all. Problem, but in this stage, main stage, triangulation, each element, how to say, is a child of all previous, and inherits the error. Computation error, so-called cumulative error. Computation error is, how to say, collected. And at some point on, for example, you do it for your phone. Your phone has a quite poor math process. This means what very fast you will collect this error in so heavy way So solution will become useless. It will work nothing because error is comparable to the precision of original physical values. It's one of the problems of Gauss technique. Also, it's quite resource consuming. Solution will require approximately double n square mass operations. It's not so how to say, not so cheap in computation burden. When we speak on electrical thing, we may take a look into another direction. Have you heard sometimes about iterative solutions? Or it's also called step-by-step approximation. Something strange, no? What means iterative solution? What's iterative solution? What kind of solution? What I'm talking about? Pirates of Caribbean Sea, famous Hollywood. So they had a compass there.
Yes.
Showing what direction to think you most need. Yeah? Let's say true solution. It's a gold. So, placement of gold is located in x1, xn with a star. I can always, any linear system, let's say x1, x3, any linear equation system means some dot in multidimensional space. It's somewhere. All the set of x, in geometry, it's a point. For our space, it's a free coordinates for some imaginable space of an electrical circuit. If you are unlucky, you have to solve this region, it will be 16,800 coordinates. Yeah. Each node voltage is a coordinate in multidimensional space. You have circuit with 4 nodes. One is base. Base node sets this point. And other nodes, voltages, are coordinates. So, somewhere is my gold chest. I want this chest. But will I get coordinates from this nice compass? Coordinates? No. I will get what? Direction. Yeah. I'm here at some point x0. I'm here. Where is my gold? I need new car, I need new house, I need a lot of RAM. What will I get? Gold Z. And I will do a step to the, let's say, point x1. It's closer to my goal. Okay, what will? Gold Z. Gold Z. I will do step. I will do step, I will do step, so it will be x2 something,
x1.
Let's say k, x, k plus 1, and so on. Yeah? Next. So, limit when k is infinity will be what? Yeah, the point where my growth is waiting. Now, one tiny moment. Several tiny moments. Let's say I started from x0, I go to x1, from x1 to x2, so next x is some kind of function from the previous. It's correct? Yeah? What kind of function? What's inside this function? Direction. Inside this function will be two things. It's direction and
The steps.
yeah, step. I can't fly. I can do only, let's say, 1 meter step. So it's inside this function. This function says, oh, here is my previous x, here is my next, where my next one. Next time, hop, hop. So this function, or iterative function, is next from the previous, next from the previous. If I'm standing here, I'll go. I need to go this way, but I cannot make infinite step. My step is limited. That's inside this function. And I don't know, I can free some space. Good. Here is my starting point. I make a couple of steps. Oh yes, ramp on my way. I will not go directly. What I will do? I will walk around. And each time, for example, I diverted from my case. What will show this compass?
Don't have direction.
Yeah, I will have direction. From the, I'm standing here, direction this way, yeah? For example, I'm here. Again, I will have direction, but different direction. But it's direction to the point. So if I make a turn, anyway I will get to my trace, because from any point I will get correct direction to solution. Understand?
This is wrong.
Yeah, I make a wrong step. And I will still go
Wrong.
I can make several wrong steps. Anyway, this compass will lead me to the target, to my goal. Yes, I will. It will recalculate. How to say? It's recalculates trace to the. Why I'm talking about this one? I can make a calculus mistake, errors. Any real math system, any real computer has a limited precision. I'm lost some precision. Not important. No problem. While my compass is correct, anyway it will lead me to the solution. Very nice. Looks very nice in theory. Black. Where's the key point? I have this compass, yeah? And it works. It's not fake, it's not drawn, it's not made of on 3D printer. And it's the whole shell. I have this working iterative function. Gold point. Starting point. One, blah, xk. Let's say the next one, k plus 1. And I don't know. Okay, here in red, real solution. Does this point exist? Yeah. Gold exists, and 2 points. Okay, I'm standing, previous, next. Both this point exist. And, of course, exists a distance. To distance from the solution to the point, previous and next. Do I know this distance? A problem. I don't know this point. But this distance exists. I just need to find them. But they do exist. Because these points, all 3 points exist, so distance exists. I can say that at the end of process, if my process of finding next as a function of previous leads to the point I needed, this means what at the end of x car goes to infinity will be 0. At the end, I'll be just in the, where I be at the end? It's the mass of, is the center of mass of this gold chest. At the end. This means what at the end is 0. Yeah? Because I will be at the point. And delta being next, previous, is also 0. But the process converges. I assume what at the end.
Can you wait just one second? Just looking at one. The second one is RK. No.
This is K, previous. Here, see, where is my imaginary? This point is xk, goes this direction. And this point is k plus 1, next one. K is a number of steps.
But how k plus 1 minus rk equal to 0?
Because it's a limited. At the end, at each step, I will be closer, 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 closer. And at the, when I'm here, my goal, I don't know, have you saw this Australian giant coins, Krugerrands?
Okay,
Australia emits 5 kilo gold coins.
I got you.
So I will be at the middle of this coin. Coin it at the center of mass. I got it. That means what distance from me and the center of gold is 0. I got it. So at the end of the travel, distance will be 0. Very nice. Okay, distance is a sum where I starts from k to infinity del I. Or, okay, I can write it in from 1 to infinity I plus distance is a sum of distance difference. Understand? If limit of the R is 0, limit of the delta also 0. Different distance between two zeros is 0. Yeah? And I can make one assumption. I can make an assumption with delta K should be greater or equal to the sum delta I plus K. It's a bit shady assumption. Yes, with this I can why I'm talking about this radius? It's precision. I need to stop my process somewhere. I need to say, okay, I'm close enough. When to stop?
When you are.
Yeah, how can I estimate distance to the
Distance between point.
between me and solution? I only have distance of steps. I have size of steps I made. I knew what this needed distance is the sum of all steps. And steps will be smaller and smaller because I'm closer and closer. Because limit of the last step, size of last step, its limit is a 0. If all this process leads to solution or converge means what all this process at the end row converges if its sum is limited. Here I have a row of distance, so if the sum of these steps is finite, I will get my solution. This moment is a bit shaky. It's a bit shaky. Let's take example of very simple progression. X next is Qx previous. For example, with Q2, what will I get? And let's say x0 is 1. 1, 2, 4, 8, 16, 42, 64, and so on. Yeah? x0, x1, x2, x3, x4, and so on. Familiar thing? Row of number. Will it converge? No. Its limit is infinite, and it will not converge. We can take another example. Another example can be Q1 half. 1, 1 half, 1 4, 1 8, 1 16, 1 32, 1 64, and so on. Converge? Yes, it's lead us to 0. And here, what will be sum of all elements of this row, of this progression? If I sum them all. 1 plus 1 half plus 1 fourth, 1 eighth, and so on. Sum of all of this equals to 1. If I sum all row, it will be 2. And here, one interesting moment. 1 and 1. X 0 equals to sum, where I starts from 1 to infinity of xi. Yeah? If I take this point, I'm here. Sum of all this will be 1/2. Really? For this progression, let's say m equals to sum by I 1 from infinity x m plus I. You see? It's an age of converge. Here, if I knew this one, it's not less than sum of all other. So why I'm talking about this? My trick with distance estimation. If distance, or let's say ratio between x is 1/2 or smaller, this will be in force. Anyway, for any q from 1 to 0, row converges. Yeah, but for any q and greater than 0, I can guarantee that any row element is equal or greater than sum of all other. But where is? It's all nice, but where is this magic compass? In all this blah blah blah, in all this talk, there is one key element. I need comps showing gold there. While I don't have it, it's only blah blah blah. Huh? Maybe good comps, maybe not so good, leading, not leading, where to get it? Where is the magic comp show? Please deliver pair. I need to call someone. Who to call? There was one famous guy in math science, Jacobi. Jacobi produced a lot of ideas in math. And one of the ideas was so-called Jacobi technique. Jacobi did a very simple trick. Let's say I have system Ax equals to B. Jacobi offered a technique where x next should be Sc x previous plus D. Here, C I dot excluding I equals to J should be minus A I divided by A I. CII should be 0. All this for I changing from 1 to the number of equation, from 1 to number of equation, and of course di should be pi divided by ai. Here is the Jacobi or simple iterative technique. Very simple. What Jacob did? Very simple trick. From the form ax to b, he solved x equals c x plus d. He just took out one unknown in each row. Or just mark next, previous, and you have an iterative form. Easy trick, but will it work? And here the problem. It may work and may not. Problem by I of xi next divided by xi previous should be less than 1. It will converge only if max ratio between next and previous is less than 1. For each, we got problem. This may work and may not. Okay, but how? How to estimate it? Something wrong here. There is one idea in a matrix math. I need to evaluate matrix C. What's the factor? I have this sequence of progression. Next as a function of previous. And it converge is q less than 1. Yeah? And of course it should be greater than 0. Or I will get how? This is matrix, this is scalar. There is one trick in math. Okay. Let's say I have, I don't know, y cx. This is matrix, this is vector, this is vector. Possible is this possibility. What I can do a trick, I can do a substitution. Where yi is lambda I x1. Sorry. I and I. For I from 1 to the number of yeah. What's the name of such lambdas? Something familiar? Eigenvalues. Eigenvalues, it's from German. Own numbers. Eigenvalues, own numbers. If it is possible to substitute this matrix form with the scalar, I will get some one called eigenvalues. There is a procedure to get them. Eigenvalue, eigennumbers, and x will be eigenvector. If it is possible to find substitute digits for the matrix multiplication, they will name eigennumber. Eigen. Own numbers.
Sir, can you repeat this one?
Once more. I have vector x as a result of product C matrix and x vector. If it is possible to find numbers So y will be this lambda multiplied by x. This number, all numbers of matrix C, or eigennumbers of the C. And x will be eigenvector. Eigennumbers. My covenant of converge will be rho max space I bigger of eigennumber should be less than 1. This is covenant of convergence. I will get solution so biggest eigennumber should be less than 0. Rho is a spectrum radius of the C matrix. It's called spectrum radius. And so what? Finding eigennumber takes not less numerical work than the solution of the system. But in matrix mass, when you open book called matrix algebra, it will, opening Necronomicon isn't so dangerous when open a matrix algebra book. There will be no way back. What you will find there? If you open, you will find one rule. And it's a rule that any canonic norm of the matrix is greater than its spectrum radius. You see something like this. C equals or greater, and the rule, come on, C. And so, point within vertical lines. What it's? Push this button to get to mental institution. What's inside it? There are several canonic norms. For us, we can use something like this. Sum I1. 1 second. Marks by I. 1 to n. A I n. I from 1 to n. It's a norm number 1. I can assume infinity. It will be marked by here. Sum I1 by AE. This one will work. Or second one, for example, a second norm will be what it will be, square root of square root sum 1 to n a square IU. Something like this. It's an Euclid norm and it's in distance. It's called Euclid norm or distance. Any norm will do. That means what in our case, for example, biggest of sum starts from 1 to n, c I j. Oh, this one is correct. Is less than 1. I should change from 1 to n. Biggest of the sum. This leads us, this is so easy, this is solvable. This means what? For each row should be great when sum changes from 1 to n, except I equals to j, I j. Sorry, I should change from 1 to the number of elements. Here is convergence, one of the convergence conditions of the Jacobi technique. What do you see? Mass. It's a bad thing. It's kind of blasphemy. Demons. Demons. What does this mean? For example, I have a row of students. There should be one taller, while all others standing, stacked together. It's a madness, no? I'm assuming you never heard about Jacobi technique. Because in ordinary life, find an equation system fulfilling this condition, it's not easy. It can be done artificial with linear transformation, but in real life, it's a rare thing. It's how to say rare bird. Toothed chicken, something like this. But maybe I look funny, but I'm not an idiot. I spent all this time. Not for useless things. Nodal voltage and contour current systems fulfill this. It's a special thing for electrotechnics. When you deal with circuit, it's an equation system, but its equation system is a numerical model of some circuit. When you have a correct model, this will work. Jacobi technique requires only n square numerical operation. It's a difference between third degree and second, and it's a lot. And it can be, future improved. How can it be improved? One top surveyor, topologist, Ludwig von Seidel, looked one day at Jacobi formulas, said, I think it's possible to improve it. I don't think it will has any, what it will produce any value, but anyway, you can do it, you can look at it. What's the idea of Zeidel improvement? One second. Let's say we have n3 and we are solving x equal to b with a technique of iterative solution. So that means what x next is cx previous plus d. Okay, let's write it. x1 next will be c11 x1 plus c12 x second plus c13 x3 plus d1. X second will be c21 x1 plus c22 x2 plus c23 x3 plus d2. Stop, said Zeidel. Ludwig von Zeidel. Wait, wait 1 second. What do you have?
x2 plus 1.
What's this? Say. My goal. I'm here at xk. I'm doing one step. For this point, I have x1, x2, x3, k, and k. Yes? I'm calculating x2 for the next one, plus 1. It will be somewhere here. But what I knew, what's in orange? 1. Here is my coordinate system. I knew 1 coordinate of this next point. Why not use it? Why not calculate? I should make step like this, yeah? To the x2. When I perform Jakob technique. But why should not? For example, this will be better. This is this potential x2, but I knew this point. I can go here. It will be point with coordinates x1 next, x2 previous, x3 previous. See, that's a trick. This point is closer. And my step will be not like this, but to this point and then from it. So at the moment when I knew next point coordinates, use it. Not go like this way, but up, 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 up. It will be some, oops, something like this. So Zeidel's idea was use the next one. Next will be C31 x1 plus 1 plus C32 x2. Also, I knew it, so it will be plus 1. Next, plus C33 previous, I don't have it, plus D3. With such improvement, it's small improvement, only plus 1, I will double the speed of solution. Real speed double, solution speed doubles. iterative form. Somewhere from I to I minus 1 ci dot x. Next, plus somewhere n from I plus 1 to number of elements ci x. And previous was the I for each I from 1 to the number of elements. Precision is another tiny trick. Actually, to get delta, to evaluate precision, I need to calculate Euclid norm every time. I don't want it. It is possible to do one trick. So, evaluate precision. Here I should be changed from 1 to number of elements. But with precision, I can substitute it with so-called maximum absolute difference. xi next, xi previous. It's a big trick because distance between 2 points is a square root of coordinate difference. Yeah, it's an Euclid norm. I can substitute and I can prove what error do not exceed 0.07. So not less than 12%. Don't exceed 0.7 because in the worst case, what I'm doing, I'm substituting vector with the max of its projections. Distance. The top error will be at 45 degrees, and it's a cosine of 45 degrees or 0.7. Oh, this thing can solve me electrical networks. Do I have time? Yeah, I do have time. Now I would like to show how to program it. I would like to show it in reality. Oh. 1 second. I need to solve it. I would like to show how to solve a system of linear equation. Yeah. 1 moment. First I need 1 second. Console, something here. Oh, it will work. TV, wake up. What a computer application without computer. What kind of computer application without computer? All these formulas are good only, I don't know, to make a sleep or to induce nightmares. Second, I will switch to this. Yeah. Actually, I don't like to be bound with some environment, but I took this SciLab because it's first free for students and it is able to perform matrix operation. You can get it free of charge from where? From SciLab.org. SciLab.org. I use older version, newer are available. You can use MATLAB or anything else. It's not very important. How to stop playing with timer? SciLab. SciLab. ORG. Dassault System now sponsors it. SciLab ORG. I used older one, you can take newer, no problem. Take a best position. Okay. What is SciLab? What's good in it? What's wrong? You can use it when you start it. Here it shows some representation of folders, and it has console. Console can be used as a giant calculator. You can use simple mass, I don't know, 2 divided by 3. What simple calculate, what I did, get a larger font. You can see, yeah. Here, simple mass operation. I also used a sine function. It has a set of mass function like sine, cosine. What's this notation? Percentage sign means constant, built-in constant. Pi, no? 3.1416 and 159 and so on. Division. Very simple inline calculator. Or not so simple. SQRT minus 4. What will happen when I press enter? I will get square root from minus 4. I got image 2 imaginary. Yeah. CLC, clear console. Very nice. But logarithm minus 1. This is capture for students who tell we got math, we got electronics, we got. What's the answer?
Log minus 1.
Yeah, minus 1. What's the log function? Power E should be put in to get value. What's the answer? It's a super capture. I love it. Ups, we got high mass, we got this, we got that. When, what? Error, it's a capture. A in complex power, what's mean? Rotation. The answer is very simple, but it's a check for knowledge of complex mass. If you have a complex plane, +1 plus y equals to square root of -1. You have some complex vector. Yeah? A, B. So x is A plus B. Multiplying it by F power dot phi. What means dot alpha? What means? F power dot alpha is better draw it like this. F power dot alpha means vector with long and angle of this is correct. Yeah? What should be alpha to get minus 1?
180.
Yep.
Pi.
This here, wait, in blue. This is minus 1, and this angle equals to P or 180 degrees. So correct answer is yod P. Imaginary P. Pi is a forbidden thing for me. My surgeon, to make me, to shame me, wrote official in my medical book a blessing. So no pies here. I can hear about pies, I can talk about pies, I can think about pies. They are forbidden. This is pi. Okay. Nice large calculator. One important moment with this nice calculator. It's an idea of arrays. For example, A equals 1, 2, 3. It has built-in linear mass with arrays. 1, 2, 3. Row vector, column vector. Everything about arrays is built in. C, maybe A multiplied by B, it's a scalar. I don't know. C equals to 1, 2, 3, 4, 5, 6. 8 is. And here in variable browser you can open any variable. For SciLab, any variable is an array, is a matrix. There I can also do things like this. C, for example, 3.2 equals to 7. I can use indexes. The first one is a number of row, the second one is column. Index in schematics is like this. First, second. Where will be third dimension? 2 dimensions is enough. So it has built-in complex mass and array operation. Array in computer logic, or in computer says matrix. You see, electrotechnic is a lot of matrix. Matrix are good because they compact. You can hide all network inside the matrix. And for SciLab has built-in array. If it has array is matrix, matrix is a circuit. So this environment is well suited for electrotechnics because it has complex. When we open the box, maybe Pandora box, AC circuits, we'll see complex numbers there. It's one thing, and second, it has all we may need with array, including eigenvalues A of C. In MATLAB, it should be AX. Sorry. Oh, here is highest eigenvalue of C. Okay. If I want everything, AK it's a X of A should produce 3 values. Largest real, smallest made, and more. It sorts them. I don't know why. Oh, AX should be find a is spec. Okay, I understood. If I need here they are. Here I'm confusing a bit MATLAB and SciLab. In MATLAB AX produce vectors, here AX produce spectral radius or something like that, and spec produces real vector of eigenvalues. It works. Okay, let's go a bit further. How can we solve system of linear equation here? At first, we will need programming mode. Here, I'm in, let's say, large calculator mode. This thing allows programming mode. I can write programs. For this it has its own editor called SciNotes. This first button is SciNotes. I can also use old style for edit win SCI. I can do it like this. Yes, created. Here I have linear system SCI empty sheet. What's the meaning of 2 slashes? Command. It shows in green. I will take, for example, here this part can be just reused. Clear, purge or erase. Without this, SciLab has one how to say interesting feature. It usually I wrote a program. For example, I wrote a program in C language. On each run, all variables will be zeroed. Yeah. Here, if I do not specify clear, variables are kept. Without the clear operator, variables are not zeroed. Here is a matrix. You can see I'm tricky. I took matrix with diagonal dominance. Yeah. How can I solve it? First, I need what I need. First, I will copy this part. What's this? Gauss. SciLab has built-in Gauss procedure. It can, this reverse or backslash calls Gauss procedure built-in, already there. For general linear equation, we don't need to bother. It has built-in Gauss solution. For electrotechnics, I had something like this. Look, this part. I can reuse my work. Both Jacobi and Seidel techniques rely on symmetrics in kind Ci minus I divided by I. For I from 1 to number of elements, from 1 to number of elements. And also di should be di divided by aii. Both techniques rely on the same thing. Let's do it. Oh, what's this? I would like to have it reusable. Size is a measuring operator. Means what's the size of your array? It takes two input parameters. One, what to measure, and second one, how to measure. One means give me please number of rows. 2, number of columns. 3, number of layers. So 1 is number of rows. Actually, matrix should be square. Next one, this just to fill C here, this part. What can be meaning of 4? For one, for something to something and ends with the n. What's the meaning of 4 from 1 to 3 and here should be something. Who runs inside the cage? Rat runs inside the cage. This means do something in circle. Repeat it. For 1 to 3 means take I and start counting 1, 2, 3 on each count, do what's written here. Yeah, simple. Jump 5. What should done? Should be done. I1. Jump of I. Jump once. Come back. Increase I. Now I will be 2. What to do? Jump twice. Come back. 3. Jump 3 times. And go.
Just 3.
Yeah, so count 1, 2, 3 and do what's inside. Or look here. Count from 1 to number of rows. Because this n is taken by a measurement. And what's inside? Oh no. What I'm doing? I have one cage counting I from 1 to number of rows, and inside will be the second one counting again from 1 to number of rows. What a wheel of torture. Wheel inside a wheel. How it will be work? Outer, count 1. 1. Inner, count 1, 2, 3. Or outer. 2. Inner, again, 1, 2, 3. Outer, 3. Inner, 1, 2, 3. How many times? Actually, they will, in such case, we will jump 9 from 1 to 9. Nine times. Okay. If for example here, it should be correct. For example, I'll put here jump yacht. How will it work? First, I1. Jump 1, jump 2, jump 3. One turn, and again, jump 1, jump 2, jump 3. And again, jump 1, jump 2, jump 3. So it will be 3 times of 1, 2, 3, 1, 2, 3, 1, 2, 3. Here I'm calculating this C matrix from Jacobi solution and D. I have ignored, Jacobi wrote also what CII should be 0, but I'm ignoring it because I will skip it in different way. Here. Oh, I can copy my work. I can copy my work. One moment, let's see. Block, block, block. Here, n is number of steps. I filled x with b just to fill, just to start somewhere. There should be some kind. See, how do I go to my goal? I should start somewhere. Yeah. Because I don't know anything about gold position, I just fill it with the B. In reality, it's better to use base node voltage, but next, what is while? It's a loop do until solution. While if for is do counting, do 1, do 3, do 4. Here, do until solution. Dig until
Solution.
here. Do it until solution. Dig until find. So here is condition. Do it until x is greater than 1e minus 8. What does it mean? 8 digits after the comma. So do until in precision is higher than 8 digits. Precision 0. Now, what's here? For do counting while do until condition. Inside xi. Next is a sum from 1 to I minus 1. I need x your next plus sum by m from I plus 1 to number of elements cin. M previous plus bi for I from 1 to the number of iteration. It's in mass. Look here. Up. This one 4 is 4. This one mass notation. Do it counting from 1 to number of iteration. Next one. X next, n means next. This element goes in. Next. Count. Yet from 1 to I minus 1. Count together, starting from 1 to I minus 1. And what's the sum? What's the idea of sum? This, all in some kind of jar. This jar is xn, x next. And to this jar comes all these multiplications. I have this one fell first. This multiplication 1 to 1. Okay. Then I need to skip diagonal element and do the second sum. Hop, 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 hop. I have them all. Now, what? Precision. I need precision. Because I need to stop somewhere. Here is difference between them and what's here. I have zeroed, look here. I have zeroed epsilon and here goes something. If do something on condition. Here, what's the condition? If difference is greater than this epsilon base difference. I don't know. Have you played some? In my time, it was a popular game, King of the Rock or King of the Cliff. No? No. Weight ball, 16 kilos. First one, lift 12 times. Just lift it. Now he's the king. What should do next one to take his place?
14.
Yeah, with 14, with 20. In short time you will get quite muscular. So here the same thing. At the first moment, throne of the king is empty, 0. Here, first, actually it's an error, it's a distance. And it is compared with this if, with the best one. If better, take his place. If no, I with 20, 11. Go. Go, son, go. If better takes a place. It's a way how to get max or min. Just take one by one and compare with the best. If better takes the place. No, you can go. Go with something. So here, after this works, I will get a best one, what means greater one. I can put my x in place. I see why can't I write instantly into large x array? Because I need precision. So I calculate a sum, it's a coordinates of the next in the separate jar xn. I compare this jar to the vector element, and then I can put it in place. This is number of step. Just increment, it's not needed. And okay, when this ends, everything will be fine. Here steps, let's correct it. What's this? Disp, it's a display operator. I will first write number of step and number of step, then solution. What means solve a system of equation? I can tell it in the way. What kind of way? How can I tell it? I can tell it find the x making it true. So a multiplied by x minus b should produce 0. It will be not 0, but it will be something. And comparing with Gauss, I have solution with the Gauss technique. Yeah. Only one problem. I forgot to switch screen. Okay, for those who watch me online, A and B matrix, C and D for Jacobi, and iterative, where should repeat until condition met, until precision is reached. Outer cycle for rows inside first sum of Seidel technique, second sum of Seidel technique, and precision. Okay, let's try to run it. Yes, save and execute. Here is save and execute. Save and execute. Results will be in console. Exec. So, here is referative solution by built-in Gauss technique. Took 10 steps. Zeidel solution yielded this x. Here is check for ax minus. I ordered how many? 8 digit after the comma. I got 10. And comparing with Gauss, 10. What this mean? 10 8 by 8 multiplied by 10 minus 10 power. Minus 10, minus 15, 17, minus 11. Very good. Maybe, for example, I reduce precision. And we will get, it will take only 7 steps in precision. No, yeah, it's in precision. Or I may want to get better precision. Here I control precision. I will get my solution in 12 steps, and here 12 digits after the comma. It's good. One only moment, in a way I wrote it, you see it's a very simple program. Okay, I copy pasted from my previous. It's not so easy to reuse it. I can switch to more usable form. Let's say I will start now. Next one, lin sys 2. Okay, I will take this part. I will reuse this part, but I will do something. Oh, I will take it here. I can declare a function. I can come here. Even here, I can start. Look what I'm doing. I can declare my own function. It's the same code, but see how I encapsulated. Function x equals to z from a and b. Inside the same stuff. And I can do what? I can write now x equals Gauss, not Gauss but Zeldel, sorry, Zeldel A, and from here I can reuse. Now run. Any mistake? At one COD. What? which means purge. Oh, now works. Here it is. Works? Where is my precision? Okay, -8, let's make it. I can use as many metrics as I want. I declared my own function and now can use it as many times as I want. Oh, one moment, what's this? In SciLab, I can do a trick. I can divide by 0. I can divide negative number by 0. Here, space of the digits is extended. It has 3 additional elements. Inf means infinity. Minus inf means minus infinity. And none, N-A-N, not a number. If you got something absolutely, it will be not a number. But here you can divide by 0. And your math teacher will not put you in corner. See, there is very, very handy environment. Very easy, isn't it? Yeah, one note, A capital and A small are different. But it has a very small amount, this very small core of language. Math operation, plus, minus, divide. Logical operation, very simple. Where are you? If, do something, if condition. If greater, if lesser. Equal, writes to equal. AQ, here different in MATLAB style. This symbol means assign value. And to such symbol is condition for equal. Greater, equal, not equal, exclamation, tilde, equal. No, not exclamation, but tilde, sorry. You can see what solution of linear equation system is very simple. But this technique, one more, this technique works fine. Take a closer look on the metric structure. See, what it has a diagonal dominance. Yeah, 2.6. This is matrix of special type. Here I have DC network where I copied it. This program solves a DC network. It's for the next time, MN and so on. Here all the solution of DC network. It produces voltage and so I would like to show one thing. See the structure G, it's a matrix of nodal. Okay. Matrix of contour currents. See, they all both electrotechnics key technique matrix has diagonal dominance.
Like they are the most valued and positive.
Yeah, positive, and what's important, not diagonal value is greater or equal to the sum of all row or all column values.
Should be greater to sum of
yeah, should be greater or at last equal. Equal means neutral convergence moment. Greater, Jacobi and Zaid has different conversions, but it will converge. This step-by-step solution, which is very easy and well works, but it works for matrix of such structure. We will get the structure just because it's the physics of the circuit. Okay.
We always study this matrix.
We will study networks, but with correct approach, our mass model for the network will produce matrix of this kind. So this fast solution technique will be applicable. Okay, where am I? What I need to do? Get a. Said what? No one watch me. Stream ending.
Oh.